Hello, everybody, and welcome to this week's Pisa Presents. And to paraphrase a very wise man, we like turtles. Yes, indeed, ever since we have pretty much been around on this earth, mankind's been fascinated with turtles. So let's look into some prehistoric turtles, shall we? Some of their evolution, early species, and also, too, just maybe some species that you may or may not have heard of, but are just pretty interesting. So now, one thing about turtles is that they're what's called a name that I'm not too fond of, but they're basically living fossils, which is a term given to species that some of the ones we show here. So bees, cockroaches, crocodiles, duck-billed platypus, horseshoe crab is another famous one, lobsters, sea stars, sharks, snakes, and turtles have all been around since the time of the dinosaurs. Now, yes, shapes change, species change, different adaptations go in and out, but still, turtles are still here and the dinosaurs aren't. So they must have been doing a couple of good things, right? Now, exactly how long have they been around? Well, that's a bit up to debate, but we're looking at words of about 230 to even over 260 million years turtles have been on Earth. Now, those various parts of Earth include every continent but Antarctica. We've been able to find turtle fossils, so they're very widespread as a group. Now, turtle classification is a Pandora's box that there is no way I'm going to open up here. It is a complete gosh darn mess. There are people that are like, oh, there's this many species, there's that many species, that group's in that group. It's, man, and you guys thought dinosaurs could be messed up. Trust me, look into turtles if you want just your brain to half explode in terms of taxonomy and things. Now, so we're going to keep things very, very simple. Modern turtles, the ones alive today, are of the order Testudines. Now, there are two suborders to the two of them. They're basically divided on how they carry and can move their neck. Now, the number of families within those two suborders is very much into debate, but currently today there are over 350 extant, meaning living, species of turtles. But obviously, there's some ones that are still in the past, fossil ones, one that has gone extinct. And so Testudinata is the clade with all true turtles, ones with a shell and a carapace. Well, a shell includes the carapace. Now, that will be extinct, which are a phrase you may see for extinct turtles is stem turtles, or ones that are alive. Now, as our little friend here is looking quite confused trying to put together his family tree, we really don't know the ultimate ancestor of the turtles or even kind of how they evolved and how they came about. I mean, I hate to give a nebulous answer, but when that's the only answer we have, that's the one we got to work with. That's kind of one of the things of paleontology, because people look at specimens and they don't really realize just how hard it is to be fossilized. Taphonomy is the process of fossilization, and not only do you have to be preserved, you fall in an area where you can be preserved, but then you have to be found and the bones be put together properly. There's so many things against fossilization that really, it's even remarkable that we have the specimens that we do. So the main theories of turtle evolution. One is that turtles arose from a group that's closely related to the archosaurs, or basically relatives of dinosaurs, or from a group related to lizards. Now, also, too, these various theories can go back and forth with some of these groups being related to another group. Another theory is that turtles arose from anapsid reptiles, or another one that they arose from what's called the diapsid reptiles. Or the fifth theory that you'll see a lot is basically just, we don't know, and then gesture vaguely at the universe, which is just kind of a cop-out theory, but still, if you don't know, I guess you really don't know. Now, another word that you may see with early turtles especially is Pantostudines. Now, that is a proposed clade. In other words, now, so when people name fossils and species, these names just aren't automatically approved. I mean, you can't just name something like Godzilla McMuffins. there's a process to this that allow names to be approved and registered and everything else. So that is kind of up to debate as to whether or not that group name is going to be approved. But if it is approved, it's going to include all living or extinct reptiles most closely related to turtles. In other words, it won't actually include proper true turtles with the full shell, but it'll include various reptiles that are basically as close to that as you can get. Now, the concern over this is that I've seen in some journals that people are afraid of this being called, this turning into what's called a dumpster taxa, which is kind of a tongue-in-cheek paleontology term that more or less references, and that there's not very a really strong description here for things, and people just kind of throw all sorts of different species in here. So I think actually that is part of the good reason why it hasn't been approved yet, but just in case you see it, that's what it means. So now the two main things about the evolution of a turtle, the two main things that define them from other species, are having its shell. Now the shell is actually not only just the hard upper part, but also that below. So the hard upper part is what is called the carapace. The part down below is called the plastron. And yes, the turtle's spinal column actually rides up and goes along the bottom of the carapace. It doesn't just go straight through like sometimes you'll see in illustrations and things, but no, that's not true. Actual turtles, it runs along the carapace. So how did the turtle get its shell? That's not really a chicken and an egg sort of question, but the theory is that over time, the ribs of turtles widened. And by turtles, I'm also lumping tortoises into this too, just for future reference. So the ribs widen gradually, and then over time, from these ribs ossifying or turning into thicker, more bony-like structures, you developed your two main parts of the shell. So we're going to look into a couple of early potential turtle species and a few early, heck yeah, that's a turtle species. First one up is an extremely controversial one, Unitosaurus. So this was from about 260 million years ago, and it kind of almost looks like a monitor lizard to me. It has a very interesting look to it. Now, that sort of puffiness to the body, granted, this is an artistic representation, but still, this is the best representation that I could find to show you guys how this is. Because when you look at these fossils, a lot of this stuff is collapsed and it's broken, so you can't really get sort of a, what's a good phrase, like the depth perception, sort of a grasp of the real shape and the mass of the animal. So more or less, its ribs on the bottom actually curved up and went over into its spine. So that is why some term it an early turtle. Others will say, no, it's not related at all whatsoever. It's completely different. It's very, very much argued whether or not this is a turtle or at all. And honestly, you're going to see answers all over the map. Now, from about, like we said, 260 million years ago, it was toothed, which modern day turtles and tortoises actually are not toothed. Now, it had those elongated ribs. Now, you can contrast that to, I just find that name so adorable, Papocellus. It actually translates to grandfather turtle. It sounds like something, I don't know, out of a Redwall book or from the Disney Robin Hood, you know, with like the animated foxes and stuff. So now, what made this one so unique? Well, 240 million years ago it was around. It was still toothed, but it had paired gastralia, which are, if you can kind of see the reddish sort of bones, like right on the middle, kind of in between its legs. Now, why is this significant? Well, gastralia are skeletal structures common in reptiles. And a theory with turtles is that they gave rise to plastrons. In other words, Papocellus is recognized as the first turtle to have a plastron, or the first what you could loosely call a turtle. Now, this is a very interesting and slightly creepy, frankly, illustration. So the name translates to the dawn-beaked turtle. It's from 230 million years ago. Why is this included in early turtles when it looks like that, you may ask? Well, it's because of the beak. It has a turtle-like beak. It does indeed have the elongated ribs, but much less of a shell-like appearance, as you can see. It looks absolutely nothing like the other early turtles. Now, this is one where things really start to get interesting. Odontochelys. The name basically the name does mean toothed turtle with a half shell. If that isn't just screaming for a Ninja Turtle mask, then I don't know what is. So this was from about 220 million years ago. It was still toothed, but it had a full carapace, hence the name half shell because it had the carapace, and it also had thick ossified ribs, which some people argue could have been the beginnings of also to the plastron as well. Now, one thing that they really argue about with Odontochelys is if it's aquatic or not. So this is a beautiful picture right here. This individual, Nobu Tamura, they do a lot of various like paleontological illustrations and everything on Wikimedia Commons and other free use image sites, and they even said controversial ecological hypothesis in the title of their artwork here, as you can see. So whether or not it was aquatic or terrestrial is something that still remains to be seen by science. Now, Proganochelys was about 210 million years ago. That is another early turtle. Its name means the turtle before the brightness. This is a life restoration of it, and you can kind of see it has like those spines above its neck, so they theorized that it couldn't retract its neck into its shell. Here is one that is compared to a lot, Proterotursis. That one, granted you can't see any of the neck fossils from there, but that one could put its head into its neck at the same time. So basically, we know from having the two of them pretty well relatively close to each other and at the same time period, you had two very core groups of turtles were able to evolve at the same time, which is really neat, I think. Now, so you're probably noticing that the time goes more recent with every one of these. So turtles looked pretty modern, by our standards that is, by the Jurassic. Then they began to spread and adapt. So here you have, this is what is now known as the first sea turtle. There will be another specimen that you may see that names begins with Santa. I can't remember the rest of it, sorry. But that one's actually 10 million years younger than this one is. So currently, the world's oldest sea turtle, right here. Protostega gigas is about 84 million years old, and it's roughly 13 foot long. Now, Archelon. I have an insane rabid love for Archelon, like I cannot even tell you. I love these things, I adore them, I just think they look so darn awesome. I like how if you look kind of through their fossil, if you're looking through that side right there, you can kind of see like where the gentleman kind of has his hand up where he's gesturing. The other bones almost look, I've always thought since I was a kid, they kind of make it look very steampunky. It looks like they're sort of gears or something, like a clock in the inside. And I just thought that was really neat for this very large, interesting fossil. So Archelon is very famous for being a very honkin' large turtle, about 15 foot long and over 30 tons. That right there is the holotype specimen from the Yale Peabody Museum, and oh my stars, I was a happy little clam when I saw that finally. Here's some more Archelon with, oh gosh darn it, another picture down there. He's meant to be on his own, right here. So, I absolutely love Archelon, as you can tell. Here is another large turtle, suggested length over 12 foot. Very few fossils. That is pretty much all we know right there. And I've said it before with other ones, that's just a thing with paleontology. Sometimes all you get is a bone, a very small bone, but it can be enough to tell that you're a different species, and it gives you enough from how these bones are shaped. You can extrapolate, well, if the angle is here to there, and that's how they're able to tell from so few specimens that this length was about over 12 foot. This one is a very interesting turtle. It kind of had a snout shaped like a vacuum cleaner. And this is also a very beautiful illustration, so thank you kindly to the artist for putting this up for use. Now, obviously, all good things have to come to the end, namely that end right there. So the whole entire, the big drama that is the giant extinction at the end of the dinosaurs brought about quite a few things, not just the extinction of the dinosaurs. So 75 to 80% of all species went extinct during the KT event. And that isn't even the largest, most devastating extinction ever. Not to sound flip, but it really isn't. Land-dwelling species were much more affected than aquatic ones. And the kicker is that every turtle family that survived that particular extinction is still extant today. So the question becomes why? Well, that's something that we're going to go into. First of all, before you start thinking about it too much, yes, that is a fossilized turtle coprolite. I just had to put it in there. That is fossil turtle poo. I mean, seriously, when you see free use turtle poo images, you darn well bet that's going in here. So, early turtles, and even turtles today, they have a very adaptable diet. They can be very adapt with their habitat. They can be both aquatic and terrestrial. So, in other words, if you're basically having a nuclear winter or if stuff's going crazy on land, then just pop into the water and you're a lot better. They have a high reproductive rate. If they have a lot of eggs, a lot of babies hatching at one time, then you have a much higher rate of survival for, say, a species that only produces one or two young at once. And they have a very low metabolism, which means that they don't need to eat as much. And also, too, some species of turtles can even hibernate more or less for extended periods. So they had to get that from somewhere. So the idea is that, and again, this is just an idea, it's just a theory, early turtles, some of them, were able to perhaps survive the aftermath of the KT event by basically going into an extended hibernation. So I know that y'all want to keep looking at that poo, but we got to keep going. So Carbonemus was found in a coal mine. So it's not just a creative name. It was upwards of 6 foot long and had a very varied diet. It even ate small lizards and other reptiles. Now, this is a very large soft-shell turtle that was about the size of a person. It was found in the Middle East in, if memory serves me right, Pakistan, actually. This is the largest freshwater turtle. I mean, if your name basically means stupendous, then obviously you can tell it's not teensy. It was from about 13 to 5 million years ago, and its largest specimen, extrapolating, weighed over 2,500 pounds it could, when live. Now, that is a little bit into the world of our wondrous terrapin friends, the turtles. So I thank you all very much for coming, and just please go out there and find some fossils. Thank you now. Bye.